So, hello everyone. Let's talk about debugging. As you might know from the keynote on Thursday, debugging is in a state of decline. So, when we talk about debugging, most of us actually use something which we would call like printf debugging, or if they scale it up, we call it logging. If you feel fancy, some of you might even use a graphical debugger, which has functionality like displaying stack traces, allowing you to step into and over method calls, displaying where you are, evaluating expressions, setting breakpoints, and so on. Thing is, that is sort of good enough for most of us. However, there is so much literature making debugging more effective. And if you look at this literature, it's not just tools, it's also methodologies building on the existing tools we already have and we already use. So debugging in itself is a skill that is distinct from programming. So when we teach programming, we usually don't teach debugging, despite like using up to 40% of our programming time to debug the program. So that's bad news, but the good news is there are actually pretty nice tools available and pretty nice skills we could learn, and literature has shown that these are most likely useful. But literature has also shown that the practical use of specialized debugging features is relatively shallow in practice. So even the basic debugging techniques, they don't really work in our favor right now. So what are we going to do about it? Well, our goal is to promote debugging as this distinct skill to be honed. And how are we going to do it? We make debugging contests. So contests, they work in other fields related to computer science. For example, programming contests, where 10,000 of participants solve programming puzzles under time pressure, win prizes, train for it to kind of get better at these types of contests. Or in the field of computer security, we have, for example, capture the flag events, where two teams are pitched against each other, one team defending a network, the other team trying to attack the network, placing a token, retrieving a token, something like that. And game jams, for example, where people program games under time pressure with a top vector specified in advance. And all these appear to work. Like people get really skilled in doing that and want to show off at these contests and win prizes. But the thing is, if we transfer it to debugging, all these skills we have seen here, they're pretty much fun on their own, right? So programming is fun, game design is fun, hacking is fun, debugging. When was the last time you had really fun debugging? So it's kind of hard. So one of our main rationale in this debugging contest is to be engaging and that our participants have fun. And you have to make a couple of trade-offs to realize this. So first, we want to host an event where the participants have the opportunity to showcase their individual skills. But it's not just about showcasing skills, it's also about picking up skills, like picking up how the other participants or contestants debug and give them an opportunity to discuss and watch them. And for the tasks, of course, the unfunny part are the real-world problems. So to some degree, we have to come up with synthetic debug tasks that are manageable within a very short time frame. So not the crazy real-world defects. So this is our contest rationale, and let me guide you through the format we came up with in the end after a couple of pilot runs. So the central element of that format is a large gathering space where we invite the observers, the participants, and the moderators in the first place. In that place, what happens is an introduction, so that everyone is familiar with the system they are trying to debug in. They see a defect which they need to debug, and they see what is the intended behavior after that defect is fixed. And once they understood what their task is, they head into separate rooms so they can work on their own and be undistracted. In those rooms, they solve the task individually. They will take some time to solve it. If they are faster, they can join us back in the gathering space and watch the other participants do their debugging task. So we live stream all the sessions into the gathering space, so that people can actually pick up each other's skills. And when you're ready, you submit the patch, and basically it's on your own to decide when you're ready with fixing the bug. So we don't provide something like automated testing. You have to be really confident that you actually fix the bug. So you have to understand the program. So we do this for every task. This is basically the setup for a single task. We repeat it for like 5 to 6 tasks. And how do we score the participants in the end? Well, if they submit an incorrect patch, then it's always 0 points. And the rest is based on how long you took to submit a correct patch. You start at 6 points and you lose a point every 5 minutes, basically. So after 30 minutes, the task is over for everyone. So you're not just emphasizing correctness here, but also efficiency, like finding the bug fast and fixing it. It's not just locating a bug, but also generating a correct patch in the program comprehension so that you are able to be confident and judge whether your patch is actually correct. So that's the main format. Up front, we have like a smaller training task so that the contestants get familiar with the environment and the setting and know which rooms to go and when to come back and stuff like that. Because it also works hybrid. So the separate room can also be a Zoom breakout room, for example. So we actually had a hybrid event where people were kind of heading to physical rooms and heading to their breakout rooms in Zoom, and we got it back into a Zoom main room. So the winner gets awarded a trophy, which is the golden bug. Like it's not really a bug, but it's our best attempt at having a golden bug at the contest. Yeah. We also did a small variation. We find it unfair that some people never have the chance to watch others debug in this type of setting. So at random, at every task, someone just sits back, relaxes, and has a chance to watch a complete session from the beginning to the end. This participant is then awarded the average amount of points of the other participants, and we try to make sure that everyone can be in this role exactly once during the contest. So what happens during the actual debugging in that separate room? Well, our participants are faced with a tool. This is the tool that actually injects the bug into the software they're working with. So for every task, it loads some sort of git commit which has the defect in it. So the tool itself is kind of off limits. Participants are not allowed to investigate the history, which modifications the tool has made. And it has the steps to reproduce the bug, so that they can work out on their own machine how to get to the bug, to see the failing behavior, and there's also the expected condition when the bug is fixed in the tool displayed. So yeah, that's what the tool does. It loads the defective change. Then participants are able to reproduce the bug exactly 1 time. This is allowed without starting the timer, so we can make sure everyone actually reaches the failing behavior and has a starting point to debug. And then they click start, and they start working on it. And that's where the time counts. If they click complete, that's the timestamp that is recorded, and the patch is submitted to us through like some server infrastructure, so we can then asynchronously make sure that this is a correct patch and award points in the end. Let me guide you through one example. So our students, all of them have written a game at one point in their undergrad lectures, a game in Smalltalk. So actually use one of these games written by students so that they have a familiar environment. So all of our participants are students or have been students with us. So it's kind of the same level, same preconditions. This game itself is about 4,500 lines of code. It's written in Squeak Smalltalk. In that case, it is still unknown to the participants. It's basically some RPG-style game where you load a ship in the corner, you navigate around the map, and you have encounters, and these encounters can trigger some combat situations, different types of combats. For example, you control your team on the left, your players, and they can attack the enemies on the right, and the enemies attack back, so you have this round-based combat. You also have positional combat where you can have like strategies and tactics and range attacks and obstacles. So that's the game. And here is a bug. So in that scenario, one of our player characters has this burn skill, and when it casts burn skill on an enemy, the enemy starts to burn but never stops. So that's the failing behavior. And the correct behavior would be that after one run of the animation, basically the combat would continue. But that's not happening here. But this is one of the examples they get. And now they're supposed to debug this example by generating a patch that fixes it. I actually brought you a complete session of one of our contestants, so that you can experience how it is to watch someone debug. And I will try to narrate this session as good as I can. So here you see our Smalltalk environment. In the top right corner, this is the tool participants see. You can see the actual descriptions and the like failing behavior and the actual behavior. So what our contestant does is they select this kind of failing burn action, but they don't just trigger it, they go into the source code. So in the source code, what you see here is a Smalltalk browser where like the second pane, these are the classes, and here are the methods, and here's the method source code, just normal Smalltalk IDE. So they find a suitable point for putting a breakpoint. So not just running into the defect right yet. And they see something called status effect. That sounds promising. So apparently that might be a status effect with the burning enemy. And they're looking across the methods, like how is that implemented, what happens there. There are a couple of animations being loaded and configured. Yeah, it's a very good place to start. Just duplicating the browser to not lose the navigation state. And what happens now? There are a couple of browsing the class hierarchy to make sure there's nothing interesting going on in the super or subclasses. There's this animation finished method, which applies a next status effect. And there will also be, yeah, here is now a breakpoint. So, no, stopped, sorry. So in this animation finished method, they're now setting a breakpoint. Self.hold is basically breakpoint in Smalltalk, right? And there's also a method that triggers at the beginning, sort of an event handler, and there's also a breakpoint now. So our contestant decided that two breakpoints might be interesting at the start and at the end of the animation. So now he just casted this burn spell, and the first breakpoint triggered, stepping through it. But there seems to be nothing interesting going on right here. There's an animation playing. And this is the second breakpoint. This is the breakpoint where this overtime effect is finished. Stepping through the second breakpoint and encounters this apply next status effect. And in this next status effect, there's something calling next link. So apparently there's something going on with sort of a linked list, maybe. I was checking the source code of next status effect. It's just a getter, like nothing interesting going on. And now he opens a debugger of the current instance, or this is an inspector of the current instance. And if you look at it exactly, what he does now is he compares the hash code of the next link of that linked list with the current element. It's a quick way to identify that objects might be the same. So the hypothesis was like, maybe this link is kind of looping back to itself. So at that point, he identified the error state. So now he knows that the next link of the element is the element itself. So apparently there is the endless loop in the list structure he identified. So now he only has to find the location where this happens. So he browses the senders, which is basically all call sites of that individual setter where the next link could have been set. Set through this method. And there was the error. And this was the defect. So down here we have seen there was a self, like the method had put itself in the next link when there's supposed to be a nil, like the end of list. So this is the patch. Now the contestant goes ahead and verifies that it actually fixed the behavior, which is one thing you should always do after debugging. That means like restarting the game, navigating to an island when there's a combat, launching combat, passing until someone has this burn skill, casting that burn skill, just breakpoints still in the system, which doesn't matter for scoring in the end. But then the game continues, like the enemies attack us now, so the animation is just played one time and everything is fine. All right, so patch submitted, that's it. And that's kind of a correct solution to that problem, which was possible in just about 3 minutes. So these are the types of problems participants get. And what you just had was sort of the experience of the observers, like watching these streams and figuring out what's going on at the side of the contestants. So this happens in this gathering space, or I just hide the labels. So this is the room, the gathering space in which we can observe the participants. You see the big screen, and this big screen has currently zoomed in on a single session, but it also allows us to have an overview over all contestants so that we see basically all streams simultaneously and can pick out the interesting ones for the observers. We also have this little dashboard in the top left corner of that screen, where we have statistics over all participants that allow us to pick up some signals, some interesting things going on. I'll go to that later. And of course, you need food. And a very important role is that of the moderator, because the moderator provides commentary. The moderator knows exactly what the system is, what the bug is, and can convey that feeling of how close participants are to actually solving the problem right now. So it's the only way to sort of make it exciting for the audience. So yeah, very important role here. And this is the dashboard I just commented on. It basically just shows, it counts things that happen across all participants. And just see the timers, how far they have progressed into their scoring, and see, for example, how many methods have been opened, how often the game has been started, how many debuggers they have used. Then someone probably hit a breakpoint over and over, like triggering a lot of debuggers. So this is a stat signal. And here someone has visited a lot of methods. What they did was they tried to compare two methods with their arrow keys, or just switching between two methods all the time, which generated this high bar, so we could basically look at what's going on there. And there are also people like, they not even open a single debugger and still solve the thing in a reasonable time. Yeah, just by reading code, right? But it's also interesting.
It could be the faster one.
It is one of the fast ones, right? Yes, almost, yeah. I don't know at which time this dashboard has been captured. It could have been in the middle, but everyone has an individual timer, because once they start, only the timer starts. So maybe they took 3 minutes to reproduce the bug the first time, not a technical issue. So yeah, but still, that's an interesting thing we had in the corner to pick up these signals. Around this event, we want them to have fun. So we don't want them to be stuck with the skills they already have, and to be sure that they know what they can do in our environment. So they get a lecture up front, a few days in advance. In that lecture, we cover the basic debugging concepts, for example, the difference between a fault, an error, and failure, what is an infection chain. We cover some methodology, like simple ones like what is a hypothesis, or also complex ones like the traffic methodology, for example. We also cover the tools, which include the graphical debuggers, stepping, so that they know that there's not just breakpoints, but also things like conditional breakpoints. So yeah, they're aware of what there is. And because it's science, in the end, we do a survey to ask participants a number of questions in the format. This also helped us evolve the format over a couple of pilot studies before we did a real large event. And the survey results are on the paper if you're interested. And just go through one question here, and that is the experience they had. So we realized that on average, the experience was fairly okay, but it was better as a contestant than as an observer. Which is like as an observer, you might have noticed when I commented on this live stream I showed basically. It's easy to get lost as an observer, but as a contestant, people had fun. I think so. Our rational engagement and fun is the primary goal. Was somewhat successful here. So yeah, here's the paper. QR code will stay until the next slide if you're interested. So to conclude, so we've just seen a like one possible way to conduct a debugging contest. I showed you some impressions from that contest on site, like the example tasks or the gathering space where we actually held the contest. So this is not the only way you can do a debugging contest, but if you want to try out new ways to do that, let me extend that invite to you to be the host of the next debugging competition. So if you'd like to be that, just get into contact with us. Thank you.
Questions? If you don't, then Tony will need to repeat your questions.
So does this microphone work here?
Yes, I think
That's okay.
The first one? Okay, so great work, great set of ideas. I wonder, what if instead of just scoring the time, we score the size of the patch? So that we don't just score someone to be as fast as possible to make it work, but we score something that looks more like a bug fix instead of just rewrite this thing that doesn't work.
So in our case, that would always be one line. So we try to keep the defect small, but
Yeah,
it would be a super relevant metric when we scale it up, like for more difficult tasks. Yes, that's right.
Thanks, really interesting talk. So I also have one course assignment where the students need to debug something, and theoretically they could go to the actual project and compare the source code there with the mutant that you give them. I guess here it's mostly for learnings, but if this becomes a bigger competition, it will be more tempting to just go to GitLab or GitHub and compare the source code there with the one that you have, and then the diff will be the patch. So how do you prevent this?
Yes, that's actually a problem. I mean, right now they were kind of in this Greek Smalltalk environment, so you can't just go to GitHub because the source code is probably not there. It's just in the environment right now. Of course, you can always cheat by using the local history of the Smalltalk image, right? So that happens. So you have to make sure this is off limits. We have the benefit that we live stream the participants. So we would kind of see if they do that inside the environment, but of course we can't monitor them outside. Like but that's difficult.
Lots of questions? Yeah.
Hey, thanks for the talk. Can you give a few words about why and how you selected the particular defects to have people investigate?
Well, so our main reason was that the defects itself should be solvable within this, like, ideally like 10 minutes, not 30 minutes, but we gave them like 30 minutes. And it has to be fun. So the more successes they actually have, like we just don't want them to be stuck all the time, right? So we want to have a success experience. The defects were not very complex in logic. And they had to be consistent in their complexity, because we tried a range of different task complexities. And if you give them an easy one up front, they have the impression that the other ones are also easy, and they get stuck because they don't expect that there's a broken data structure when everything was just a flipped Boolean, for example. So the other consideration was having a very small corridor of difficulties so that you don't get wrong expectations. And of course, we wanted them to be creative and try out debugging methodologies within this 30 minutes. So, yeah.
So I have another scoring function question. So your scoring gives the same number of points to submit a totally broken patch and take longer than 30 minutes to submit a patch. This seemed, I don't know, this surprised me. Did you consider giving like negative points for submitting a bad patch?
Now we try to keep it very simple. I think this was mostly the reason. So this was kind of the simple system that can come up with rewarding being fast and rewarding correctness. And yes, correctness is sort of a binary decision here. If you scale it up, maybe you need a more fine-grained or fairer like scoring system. Yeah.
So running it as a competition, competitions are zero-sum, right? There's like a winner.
Yes.
And that may kind of turn some people off. So you did a survey. I wonder if you did crosstabs on the survey to see different participant demographics and see whether certain demographics might have appreciated the competition best.
I don't think we have any large variation in demographics here. It's mostly people.
Well, that's kind of a problem, right?
Yes, it is. Yes, right.
There should be more variation in demographics.
Yeah, we didn't have that. This was mostly former students or former students or postdocs or like industry people who have experience in Smalltalk.
Yes, so in regards to the engagement and fun part, yes, it's a topic is okay. It's written by like one of them themselves. It's fun to watch things move, but doesn't work. And I think it's a great topic for this. But at the same time, like in other settings, people may have to debug like error in the string manipulation such. And do you have any ideas to make that other kind of debugging tasks more engaging and fun drawing from this?
I mean, it would be difficult to integrate that into such a contest because like these real-world tasks, they could manifest, for example, at like multiple locations in the program. So we had to be really careful with the task description. Like, do we just enter one symptom or all the symptoms that like a broken string manipulation, for example, would manifest in? So if contestants actually find another phenomenon that also relies on that bug, like, should they fix it as well? So kind of, if you think about string manipulation, there are like multiple ways that can go wrong. And in the game, you can just make something that has one graphical anomaly. So that would be one problem. The other problem might be if it's like too puzzly, then we would need to give them more time, right? And if these tasks get longer, then the faster ones would have to wait until like people eventually finish with their task before starting the next one. So that format where we synchronously solve tasks would be a bit limited if they have like puzzly problems or mathematical string manipulation, database problems, anything like that. Yeah, and there's also the technical side. These types of problems are pretty much well contained. If they have like real systems, then yeah, database might work on one PC but not on the other. But these are all considerations you probably need to solve to have these types of tasks. But then they would actually like learn real world skills maybe, or we get better at it.
Okay. Very nice talk. Very cool stuff that you're doing right here. Just two questions. One, I noticed that you are debugging in Smalltalk, and Smalltalk has kind of its own very particular way of doing stuff, right?
Yes.
So I wonder how can you actually, or you have thought about how you can extend this to some other kind of programming language, IDEs, stuff like that. And my second question is, whenever I debug something, I mostly introduce more bugs. So I wonder if you have some insight about that.
The second question first, because that's the one we haven't really incorporated into that contest format. So if the behavior is fixed, then it's fine, but they are very unlikely to introduce a new bug because it's mostly a one-line fix, right? So we didn't really like punish them for breaking another functionality, I guess. But that also didn't happen during the contest. And the other one is a bit more complicated. Your first question with with porting it to different systems. Like mostly, you need to make sure that the training is sort of like that contestants have kind of level playing field when it comes to training. So we could use Smalltalk because everyone has this Smalltalk lecture at our university. If you find a system where everyone had a lecture in, for example, where everyone was kind of equally skilled to start a debugging contest, then this might work as well. Of course, there are lots of systems which have similar debugging tools like Smalltalk. Like if you have the stepwise debugger, like we didn't even use like super advanced debugging features here. So if you have Eclipse, IntelliJ, like the same format might actually work there. Yeah, but we didn't try it out yet. We're happy to be the one who does it. Yeah, and the particularities of Smalltalk is something we also noticed in the surveys, because Smalltalk is a live programming environment. And that helped shortcut some of the debugging tasks you see here. Like you didn't just need to restart every time. You could just stop the game and actually change the code while it's running, and then try out a new behavior basically in your next click on the game, or when you restart it. So that's something that shortcuts things for our competition. I don't know if you can like get this experience in other languages. Like you probably wouldn't be able to get this in C++, right? So yeah.
C++. I think that's probably all we have time for. Can we thank the speaker again?